right, so the one that I wanted us to look at is number 4. So this is the function. And the interval that we're looking at is -3 to 2. So part A was, does this satisfy mean value theorem, yes or no? And so the answer was no. And then, so for B, you had to put why it was a no. And so the reason is the function is not differentiable at x equals 1 due to a sharp edge. And I had a lot of people write like, there's a sharp edge. And I only took off half a point for that. The problem is the vocabulary word they're going to be looking for there is differentiable. The conditions for mean value theorem are that the function has to be continuous and differentiable. So that word is important. And this at x equals 1 is also really important too. You have to mention where the problem is because 1 is on this interval. Say this was a different interval, like 7 to 12. 1 wouldn't be on that interval, and so then the answer would actually be yes, it wouldn't be an issue. So the fact of where the sharp edge is important, so just make sure that you say that. It was actually the only thing, and that was a really like kind of silly little thing. Most people said this and just left out that one little part. So I'll open it up to you guys, what you want to ask about. And so someone said 2, so let's go back to number 2. 2 was another one you had to justify. So writing out a sentence here. So this is the function, and we're trying to prove that there is an output of 2 somewhere on the interval -3 to 0. So it's intermediate value theorem. We're going to plug in -3 and we're going to plug in 0 and show that 2 is in between them. So you have to show these 2 outputs because what you're trying to prove is that 2 is in between them. So you have to show these. Right, so if we plug in -3, let's see, that's going to be 9 minus 3 would be 6. Minus 1 would be -7. Should I write this problem down right here? So -7. And then if I plug in 0, I'm going to get -1. Oh, hold on one second. Sorry, I did that math wrong in my head. I'm like, hey, wait, 2 isn't going to be on there. -3 squared would be 9, minus 3 would be 6, minus 1 would be 5. I did a -6 in my head. I apologize. 6 minus 1 is 5. Remembering how to add and subtract here on Monday morning. Okay, so 2 is in between those, which is what we're trying to prove. Now you also have to mention the condition for intermediate value theorem, which is that the function is continuous on this interval. So since the function is continuous on this interval, which it is, it's continuous everywhere since it's a parabola. And now here's where you can kind of mention this in whatever words you want to put it in, but you have to say something to the effect that 2 is in between these other 2 values. So f of 0 smaller than 2, smaller than f of -3. So since all that is true, and then you can basically repeat the wording of the question. So there is a value c on this interval such that f of c equals 2. And I didn't take off if you didn't say by intermediate value theorem, but just make sure you put what theorem you use on the AP exam. I had a lot of people write f of c equals 0. I understand why that happened. I think the one we had done in the notes when I taught it was 0, and if people were like thinking back to that, they put 0. What this question was asking you to prove was that there was an output of 2. So, so just make sure you are careful with reading the question. All right, what else would you guys like? Do you want to pick another one? Number 5. All right, find the coordinate point x, y of the relative extreme. So I didn't tell you whether it was a maximum or minimum. That's what I'm asking you guys to find for this function. And you're not given an interval. All right. So maximums and minimums come from critical points. So we're going to do derivative equals 0. This derivative, e to the x, that would be itself minus 1. And we're going to set that equal to 0. So we will add over the 1. And then to get rid of e, we're going to do ln of both sides here. So ln and e cancel. That was the whole point. We get x equals ln of 1 is 0. So our critical point is at x equals 0. And I'm going to make a number line for this first derivative and see whether this changes positive to negative or negative to positive. That's going to tell us whether it's a maximum or minimum. So I'm going to pick a value over here. I'm going to try -1. I don't know what e to the -1 is, off the top of my head, but I know a negative exponent is going to flip that. And I know that e is about 2.7. So if you want to just try to round that to 3, you don't need to figure out what this is exactly, just whether it's positive or negative. But if you think of this as something like close to a third -1, that result's going to be negative. And if you pick something bigger than 0, like 1, you would have e to the first, which is e minus 1. So that's about 2.7, or if you round it to 3, -1, that's going to be positive. So we had to change negative to positive. That means relative minimum is, and I asked you for the whole coordinate point. So you're going to have to take 0 and plug it back in for x. So e to the 0 is 1. Minus 0 plus 2, that's going to give you 3. So your relative minimum is the 0.03. Anything else that you guys want to look at from this test? Number 7. Now I'm not going to do all of 7. So is there a particular part of 7 that you want to pick? All right, letter C. So here is the function that we're looking at. And we're going to need to get the derivative. All right, I'll do C and D, and then we'll need to be done going over the test. If you have any other questions on the test, swing by office hours and I can answer that for you. All right, so this derivative is going to be 2x cubed plus 8x squared plus 8x. We're going to set that equal to 0. And I'm not going to go through working all this out for the sake of time here because you guys asked for part C. If you factor this, your critical points that you're going to get are 0 and 2. And then we're going to need to make actually, you know what? I'm going to have to go through the whole thing because I can't get to part C without using those factors. I'm going to have to do the whole thing. This will take too long, but I'm going to have to go through it. All right, if we factor out a 2x, that's going to leave us with x squared plus 4x plus 4. And this is going to split x plus 2, which will be x plus 2 squared. And so we get 0 and -2. And then we're going to make number lines for each of the factors. And so this one's going to be negative and then turn positive. This one's going to be positive the entire way across. Why is that? Why is that one going to be positive the whole way across? Yeah, good. Squared means it's going to be positive. Anything that you've squared is going to be positive the whole way across. So part C, I'm asking for a sentence for each of these critical points. Let's do 0 first. F of x has a relative minimum at x equals 0 because the derivative changes from negative to positive there. And then for -2, there is no change, stays positive there. So f of x has neither a relative maximum or minimum at x equals -2 because the derivative does not change sign there. All right, and then part D, we're going to get the second derivative. So the derivative of this. And so that is 6x squared plus 16x plus 8. We're going to set that equal to 0. I'm going to divide everything by 2 just to make the numbers a bit smaller. And then that is going to split 3x and 1x. 4 is going to split 2 and 2. And these are both going to be positive. So we get x equals -2/3 and x equals -2 for our inflection points.